top, we factor the bottom, and the bottom cancels. All we were left with, is y equals 2x minus 1. We agree? So we are going to draw that line. That's the graph that we're given. When everything cancels off and your point of discontinuity cancels off, you're left with the graph. So let's go back down here. We have y equals is it 2x minus 1 that cancels? Yes?
Yes.
Okay. So when we draw a line, we don't need our calculator because we're so smart. We just start with our y-intercept. We're taught in grade 10. So we have -1. And then we rise before we run, or we're running in bed. So think about it in the morning. You have to rise before you run, or if you run before you rise, you're just literally just pedaling and you look foolish. So we have to rise, and then we run, because we're late and we didn't want to get out of bed. So we're rising up to right 1. Up to right 1. I didn't need to put that line, and I'm not erasing it. Pretend it's not there. Up to right 1. Up to right 1. Up to right 1. And then if I run out of room, I can do the complete opposite, right? Because these could both be negatives, and the negative sign would went away. So I can go down to left 1. And then I connect them. Previous to connecting them, though, what do I still have to remember to put on here? Point of discontinuity, which we found was -3 and -7. And then this is where you like shouts of joy happen if the point is actually on the line. So -3 and -7 is this one, correct? So I got to take it back out. I go in with my little marker. And I make an open dot. Go this way. Hey, that wasn't too bad. Good Friday. And then that way. Normally it gets a little wonky as I go along. But you have that open dot and it screams, I'm so good. That's what it does. I did this well, you know? So, when your numerator is a greater degree than your denominator, they cancel off. You're left with a line with a point of discontinuity. Every single time. In calculus, you could end up with slant asymptotes and stuff like that, but not here. Slant asymptotes occur when nothing cancels off. So like you have a numerator greater than the denominator, but nothing cancels. Which won't happen in grade 12, 30-1, so that will not be on your diploma. So we talked about when the numerator is a smaller degree than the denominator, our horizontal asymptote was at y equals 0. When the numerator was the same degree as the denominator, we took the leading coefficients, made a fraction, and it was y equals that. That was our horizontal asymptote, correct? Now if we look up at these ones, this one, the numerator was a greater degree than the denominator. I told you cancels off, you get a line, and you get a point of discontinuity. So let's go through here. We need the x-intercept. How do we find the x-intercept? Right, y equals 0 into the simplified version. Don't put it into the complex one because you just have to factor it, cancel it off anyways. So we're going to go 0 equals 2x minus 1. So we 1 over, and x equals a half. The x-intercept is always a coordinate. We do a half and 0. When we want to find the y-intercept, we do what? Plug 0 in for x. And then the domain is just going to be what the asymptotes are, right? And the point of discontinuity, what the range is, and the point of discontinuity. This one doesn't have any asymptotes because it's just a line. But it does have the -3 and -7. So instead we're going to go x such that x can't equal -3. X in our reals. And for range we're going to go y such that y can't equal -7. Y is known in the real. I don't know why it's in the domain spot. And an interval would be negative infinity to negative 7 round bracket or negative 7 to infinity round bracket, right? Okay. The other two examples I have are both same degree. If they're the same degree, we're going to be able to take their leading coefficients to get the horizontal asymptote, correct? But these are the same degree, degree 2. Whenever they're the same degree, degree 2, you're going to get a vertical asymptote, a horizontal asymptote, and a point of discontinuity. You're going to get two factors that cancel, and then two factors that stay. The two factors that stay represent the rational graph, which gets you asymptotes. The two factors that go away represent the point of discontinuity. Okay? Whenever you have degree 2 over degree 2 in 30-1. So we're going to do the work down here. So we have x squared plus 5x over x squared plus 7x plus 10. And then we have to factor. Oh, I moved the board and it. So we take out an x, and we have left with x plus 5. What multiplies to give me 10 and adds to give me 7. X plus 2 and x plus 5. The x plus 5's cancel, so I know I have a point of discontinuity immediately. What is its x value? I need a coordinate, right? It's negative 5 and something. How do I get the something? Yeah. Nope. How do I find the y that it goes with? Yeah.
Plug that x value into simplifying.
Plug the x value into the simplified. Remember, this is a standard of excellence question. So we get negative 5 over negative 5 plus 2, which is negative 5 over negative 3. So it's positive 5/3. Then we have the graph we're going to draw. So the graph we're going to draw is the rational graph x over x plus 2. That is the graph we're going to draw. And then after we're done drawing it, we're going to go to negative 5 and 5/3, and we're going to put an open dot. That's all we're doing, right? The simplified version is what we draw, and then we go back and put the point of discontinuity in. Make sense? So the last simplified version was a line. So we drew a line, and then we put point of discontinuity. This simplified version is a rational. And when we get a rational, we're going to get asymptotes. So my vertical asymptote's the easy one, because my vertical is the x one, and it's just where the what is. Yeah, the non-permissible value. So it's going to be x plus 2 can't equal 0, because your denominator can't equal 0. So x can't equal 2, or negative 2, sorry, is the domain. But what is the actual asymptote? X equals negative 2, because it's where it exists. The horizontal asymptote, we use the rules. If the degree of the numerator is the same degree as the denominator, which this one happens to be, degree 1, we take the leading coefficients and make a fraction. So it's 1 over 1. So my horizontal asymptote's where? Yeah. So I'm going to put those in first. I'm going to go x equals negative 2. Thanks, board. Now some people, I've done this every single time in the past. I draw a dashed line on x equals negative 2. Then I come to the test, and everyone does not draw it. And I'm like, I swear to goodness, every single time we did this question, I drew a dashed line. So you have to draw a dashed line. Like if I do, you do. You know, like we work together as a team. So at x equals negative 2, it's going to be vertical. And that's where that asymptote's going to be. And my horizontal is at y equals 1. So I'm going to go there. Now they're either going to be in opposite quadrants here or opposite quadrants here. Okay? Type in y equals 1 over x into your calculator. Y equals 1 over x. Because that's the parent function. Just like y equals x squared is the parent function of a quadratic, you know? Y equals square root x is the parent function of a radical. Y equals 1 over x is the parent function of a rational. So the parent function of a rational, 1 over x, actually lands you here, correct? Any reflection is going to land you in these ones, right? If it's a reflection in the y-axis, this one's going to go here, that one's going to go there. If it's a reflection in the x, this one's going to go here, 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 right? Like they're going to move. Did this one have a reflection in it? It's just x over x plus 2. Looks like probably not. But let's type it in. So we're going to type in the one that we have left over. We're not going to type, you could type in the original, but I'm going to type in this one. And how will I catch if you made a point of discontinuity is not going to be on the graph. Like that's how you'll catch if you made an oops, right? So you're going to go x divided by x plus 2. Now if you have the old calculators, you have to put the x plus 2 in brackets, right? Where your calculator is going to go x divided by x and add 2. If you have the new ones, I would just use the fraction button. But if you use the fraction button, your table will be in fractions. Just keep that in mind. It won't be in decimals. So I always go x divided by x plus 2 in brackets. Yours is in decimals? Did you put it in a fraction mode? So you have your table set to go to decimals. It depends on your table setting. All right. So we are going to go second table, and we're going to plot some points. Wow, someone started this at 105. I'm going to change my table start. So I have negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you know what's better than 2 points? 15. You know? That's better. That's what it is. The more you put on there, the more accurate your graph is, right? So we have negative 9 and 1.25. Or negative 10, sorry, and 1.25. Negative 9 and 1.28, so a little higher. Negative 8 and 1.3. Negative 7 and 1.4. Negative 6 and 1.5. Negative 5 and 1.6. You'll see why this actually reflects, because we'll turn these into transformed form on Monday. Negative 4 and 2. Negative 3 and 3. Now some people will say negative 2 error. I don't know where this goes. But guess what? Your calculator does. It knows a point between negative 3 and negative 2. If I go second, trace value, and I put in negative 2.5, it'll give me negative 2.5 and 5. Like you can find decimals. If you do a second trace value, you can put in negative 2.5. I can go second trace value and I can put in negative 2.25.
So why would you do second trace value? Why don't you just do trace?
Because yours can do that. These ones it just pulls its value. I'm doing it so that it's actually more distinct with value. I don't like the trace button. 1, 2, 3, 4, 5, 6, 7, 8, 9. The reason why I stay as far away from the trace button as possible is people will just like let the cursor move and then they'll give me that as a decimal. And it's like always like 0.1 off and it makes me cry because then my response still is wrong. So I try and stay away from the trace button. Like I pretend it doesn't exist. Just the second trace button exists. So then we connect these. Oop, pretend I connected those. And then I would say do better on the test if that was yours. Like go through the dots, but the board I'm not that great. And then we go back to our table, and we have negative 1 and negative 1. And we have 0, 0, 1 and 0.333, 2 and 0.5, Cleaning off. Okay, I want another one between -1 and -2, so I'm going to go second trace value -1.5, and I get -3. And then I'm going to go second trace value -1.75, and I get -7. Oh, goodness. Send those ones 3 points. Make yours better than mine. Okay. Then people will be like, I'm done. So sometimes what I'll tell you to do, instead of actually sketching the graph right off the bat, I'll sketch the vertical asymptote, I'll sketch the horizontal asymptote, and I'll immediately put a point of discontinuity in there. Because what's the biggest error? People forgetting to go back and put that point of discontinuity in. So the point of discontinuity we found was at -5 and 5/3. 1, 2, 3, 4, 5. See? And then you do this. Oh, goodness. I'll even make my point of discontinuity a different color so it really stands out. But because my point of discontinuity actually landed on the graph in the right spot, I feel confident, right? I feel like maybe I didn't screw up. Good job. Okay? So let's fill in what we know. Vertical asymptote was at x equals -2. I can't even remember. Y equals 1. -5 and 5/3. Correct me if I'm wrong, because I'm just going off my brain. X-intercept. Where do I find the x-intercept? How do I find the x-intercept? You put the y equals, you put 0 in for y equals is true, into the simplified one, right? So we would go 0 equals, I really wanted to move, but then it's new. X over x plus 2. Now I want you to notice something. I'm immediately going to multiply by that x plus 2, right? Oh, there is. There is. This cancels. And then this can become 0 equals x. So it's going to be at 0, 0. Let's think about this. If every single time I have the simplified version and I'm finding the x-intercept, the bottom cancels and this top piece is just going to be my factor of my x-intercept, then every one of these questions, when we have it as a squared, whenever we have a rational with a point of discontinuity, it's going to be in the form x-intercept factor. This is going to be my vertical asymptote factor. And what's these going to be? Yeah, x of POD, right? Sorcery. That's what it is. Sorcery. So we'll look at that in a second, but I just want to prove a point that when you have a rational with point discontinuity, it sets up that this is always your x-intercept factor because the bottom will cancel off, right? Okay. Y-intercept ends up being the same thing. Y equals 0 over 0 plus 2, which is 0. Domain and range is where everyone messes up. Domain is what the x's can't be, all the x's, including the point of discontinuity. And the range is all the y's, including the point of discontinuity. So my domain is going to be x such that x can't equal -2 because of the asymptote and -5 because of the point of discontinuity. I often only get one number here. And then my range is going to not be in that box. My range is going to be y such that y can't equal 1 and 5/3. YER. So basically, the moment I ask for the range of this, I'm kind of asking for standard of excellence because I'm making you find the y with my discontinuity, right? Okay, B, you're trying it out. Go. B is you. My computer is lagging so bad that it's making me like so hurt. Yes. So then we have to find our y. So we go 3 minus 4 over 3 plus 3, and we get negative 1 over 6. So we're going to get y equals negative 1 over 6. What am I doing? What am I doing? Okay, what are my asymptotes? Vertical asymptote? What's it at? X equals negative 3. That's my horizontal asymptote at. Y equals 1 because they're the same degree and our leading coefficient is 1 over 1, right? If we sketch the graph x minus 4, we should have an open dot at 3 and negative 6, horizontal and vertical asymptotes at negative 3 and 1. Our domain is going to be x can't equal plus or minus 3, and our range can't equal 1 and negative 1/6, right? Okay. So, how do we come up with an equation of these graphs, right? So what they would have to do is they'd have to give you some actual asymptotes on the graph. So they'll go like this. We'll pretend that it's there. It's probably at 1.5. I'm going to undo that. We're going to say it's at 1.5 because I'd rather have, no! Yes, come back. Come back to me, my little friend. All right, so we're going to say 1.5. Remember, they would have to give those to you. That's not 1.5. 1. Struggling. Okay, and then x equals what? Negative 4. So if I give you, no, why is it? It's really trying to. I don't have time for this. Okay, so we have to come up with an equation. Y equals that. Remember I said this is going to be your factor of your x-intercept because remember we brought our denominator up, it went away, and then whatever was in that bracket was our x-intercept every single time. Do you agree? The bottom was the what? Yeah, for A. Okay? Vertical asymptote. So if you don't have a point of discontinuity, that's all you'd have. X-intercept, vertical asymptote, boom, right? We'd have to solve for the A value in front. There's going to be an A here because we could actually have a vertical stretch, right? Because the vertical stretch actually doesn't affect your x-intercept at all. And your back is your P of D if it exists. But remember, it would have to be on both, and it's the x of the P of D. Here and here. And then it would cancel off, right? So let's go through what we do know. What do we know? What is our x-intercept at? It's at 2. So what would its factor be? X minus 2. Someone whispered, and I agree with you. And then, ooh, look at that line. And then on the bottom, I need my vertical asymptote. What's it at?
plus 4.
Yeah, it's at x equals -4, so its factor would be x plus 4. Exactly. My point of discontinuity, what's it at?
Oh, 1.5.
Well, this is -1. What is it? This is
Oh, that's
-1. I love Google, but when it does things like this, we're going to say it's at 1 and -0.25. So that doesn't, no, -0.25.
No, it's not negative 0.2, Nathan, you're wrong.
It's 1,
No, I think it's really good one.
it's 1 and -0.25. Can't be positive, it's below. Oh my gosh, we're going to go with,
Yeah.
huh?
But it is 1 square away from.
It's half the squares.
It's half a square.
No, there's 5 squares from 0 to.
You want it to be 0.2?
Are there?
-0.2? There are 5. 1, 2, 3, 4, 5. Okay, we'll go with that. -0.2. I want 0.2 as wow. I want 0.2 as a fraction, which is -1/5. So that's your point of discontinuity. Now, the reason why we need that, they would have to give it to us, is because this is going to be our xy that we're going to plug in to solve for our a. But the x is really what's the only thing that goes up here, right? I would get x minus 1, x minus 1. We agree? Remember, you always have to solve for an a. When we did polynomials, you had to solve for an a, correct? When we looked for x squareds or x cubes or whatever, we did our factors. We still solve for our a every single time because we look for that vertical stretch factor whenever we're looking with factors. Now, to do that a, we would plug this back in. Now, we're going to plug this in without the 1s, though, right? We're just going to ignore those for now to get our a, because if we plug 1s in here, we're going to get 0 over 0. The whole thing's going to cancel. So we're going to go, nope, we're going to go -1/5 equals a 1 minus 2 over 1 plus 4. So we get -1 over 5 equals a times -1 over 5. So I'm technically going to do what? Multiply by -5 over 1, right? And 99% of the time, my a is 1. And it was useless for me to look for it. But there's that 1% that they can make your a not be 1. Right? So you hope that if you forget about the a that it's 1. But it's not always 1. So our actual equation for this would be y equals x minus 2, x minus 1 over x plus 4, x minus 1. If it's just a line, remember if it was just a line, it's going to be x squared over degree 2 over degree 1. This will still be your x-intercept, and your point of discontinuity will be here, but you just won't have the vertical asymptote. Right? That's the only difference if it was the x squared over x. Now, I say that because you're going to have some of them in your homework. And I want you to do your homework. So on Monday, I'm going to check your homework. I'm just going to check it every day from now to the end of time. That's what I'm going to do. Because I do it in calculus, I check every day, so might as well start now, right? What's a better time than the present?
Tomorrow. Yeah.
Monday.
Next week.
Monday. That is when I'm going to.
Well, actually, that is good.
Yeah.
I'm waiting to wait for you. Yeah, it's in general.
No.
Um, 7 and 8 are the ones where they give you information and you have to make the equation. 7 and 8 are ones that people struggle on the most, so try them out. 8, I just want you to do B and C. Uh, 5 and 6 are matching. Can't really shorten it.